Okay, science has really brought a lot of blessings to man, such as what introducing new technologies, drugs, machines, electronics, and the list are endless. But do you know that a lot of people don't really understand how science works? So the goal of this video is to teach you about the scientific method, which is very important methods scientists have used to introduce what new things in our present world today. So what is science? Science is a systematic way of thinking that is based on evidence and what logic. Science is all about finding facts. Scientists try to understand the universe, how things behave, how things interact, the changes in the world. And so science is very important in the lives of many of us today because we are really benefiting from science. The clothes we wear, the food we eat, everything, the preservations we use in our farm, all those things are some of the products from science. So the scientific method is a systematic approach to research. Understanding the scientific method is crucial for advancing knowledge and innovation. By following a structured approach, scientists can uncover new insights and make significant breakthroughs. So understanding scientific method can enable you to advance what knowledge. There are many gaps in knowledge. So when you understand the scientific method and conduct research, you might end up solving some of the problems in the world and thereby closing the gap in knowledge. Some of the benefits of this scientific method, that is understanding it and be able to apply it, it can enable you to win the Nobel Prize. You can say that the Nobel Prizes are we have in physics, physiology and or medicine, chemistry, literature, peace, and economics. And it comes with with a huge amount of money, approximately 1 million US dollar. This is huge money that you can use to change your life and the lives of many. And there are many persons that won these Nobel Prizes. I'll just show you two notable people that have won it. We have the Albert Einstein, which is one of the famous scientists in this present world today, and Marie Curie. So these persons have really made significant contribution to man because they understand their scientific method and they utilize it in the right way. So it is very important you understand the scientific method. So it all starts with what observation. As a scientists try to observe things they don't understand. Observation is events that happens, event that happens in our macroscopic world. So scientists try to observe things they don't understand, and this leads to asking questions. So scientists begin to ask questions. For example, scientists might begin to ask something like this: why does this iron change from its normal nature to this brown? But because of there is a limitation in knowledge, they will not be able to answer this question, and this will warrant them to carry out research. So scientists conduct research now to know that someone has already asked the same question they're asking, or the person has already answered this question they're asking. So research can be done in the library. Because in the library they have millions of books that will help you in your research. In the internet, there are contain millions of journals. There are millions of journals, articles you can find in the internet. Or you can also ask an authority. An authority can be an expert in the field of science, or it can be a professor, your teacher, or anybody in this among these persons. So scientists conduct research to gain knowledge about it, because without having a background knowledge, you'll not be able to solve the mystery. So after they have conducted research, scientists begin to formulate their hypothesis. They formulate their hypothesis. So what's an hypothesis? It's a potential explanation for an observation based on current knowledge. Because of that gathered enough knowledge through their research, they will be able to formulate an hypothesis. So what makes a good hypothesis? Scope, is it testable, and is it falsifiable? Let me explain. Scope has to do with the focus. Hypotheses that has wide scopes tend to explain a range of phenomena. Why hypotheses have what a narrow scope tend to what to explain a specific what example. Is it testable? Every hypothesis must be tested in the lab by conducting experiments to know whether it is actually true or what wrong. For your hypothesis to be scientific in nature, it must be falsifiable. For example, if you say ghosts exist, it is not scientific in nature because it cannot falsify it. It cannot be falsified. Do you get it? It cannot be tested and doesn't have a scope. So after scientists after they have made their hypothesis, the next is to make a prediction. A prediction is a statement based on hypothesis that can be tested. You understand? So every what makes a good prediction is that it must be tested, it must be specific, and it must follow the hypothesis logically. So, for example, now let us use our iron rust. If your hypothesis is that iron rust because of the presence of what water and what oxygen, your prediction will not be that if you put iron inside water in the presence of oxygen, it will rust. That you can see is kind of what specific. Let me show you another example. So another example is that let's say eating a diet containing a large amount of saturated fat causes a high blood cholesterol level. This is hypothesis. Your prediction can be that people who eat large amounts of what saturated what fats will have a high level of cholesterol in their blood. This is kind of what you can see. It's kind of what specific. It's kind of what generic in nature, and this can allow you to collect blood samples of people, analyze it, conduct experiment, analyze it, and what bring out what result to know whether actually people that eat large amount of saturated fat really what have this cholesterol in their blood. You can see that the science method is very sweet and easy if you really understand how it really works. Science is very interesting if you understand the scientific method. So the important aspect of it is that you have to what plan what a good investigation. You have to design your experiment carefully in order to be sure that your data that you collect will not will not be biased. Understand? And also so that error will not set in, and so that you get what an accurate data and what a precise what data. So you can conduct your experiment in the laboratory if it's something that you can actually do in the lab, or if it's something that you cannot do in the lab, you conduct all the scientific studies. For example, things that have to do with climate change or climate cannot be done in the lab, but you can do it in the field. So this kind of thing you conduct all a scientific studies. Before what you carry out the experiment, you must plan your variables. What are variables? Variables are those things that can be changed. That is anything that can change. So we have three kinds of variable. We have independent variable, we have the control variable, and also about the dependent variable. Let me explain. Independent variable is the thing that you change to see what happened to what dependent variable. Let me explain. Anything you change in the course of your experiment is called the independent variable. The thing you measure or observe is called the dependent variable. Control variable are those things you must keep constant in order to have what a fair test, in order to be sure that what is actually affecting the dependent variable is the independent variable. For example, if you want to plan an investigation to know the effect of what temperature on rate of reaction, changing the temperature is your independent variable. Your dependent variable is the rate of reaction. How does it change when you change the temperature? Does it increase or decrease? This is what your dependent variable. This is what your variable is all about. So as you are changing your temperature, it represents your independent variable. To see what happened to what your dependent variable is, what the rate of reaction. So control variable can be those things you keep constant. For example, if you are reacting zinc and hydrochloric acid, the concentration of the acid, the volume of the acid are what you must keep constant. They are the control variable. You must control it. While the mass of the zinc you are using is also what the control variable. You can see that you must try as much as possible to keep all factors controlled. So in order to have a fair test, in order to be sure that what's actually affecting your result is the independent variable. Scientific is very sweet. And what you have to be careful in this part is that error can come in. You understand? So you have to be careful not to allow error to come into your experiment and make your result as accurate it can be and as precise your data can be. Understand? So you have to check on our videos on error, precision, and accuracy to get more insight about how to make your result or your data accurate and precise, and what, and to know the sources error can come in what your experiment. So after scientists have conducted their experiments and collect data, they have to analyze data, they have to interpret the data to see whether this data is consistent with their hypothesis. Do you understand? So you can present your data in form of a table or a chart, or in other words, to make this thing more presentable and more analyzable. So scientists present the work in table, that is, the table helps you to organize your data, while a chart enables to present it in a pictorial form. People really appreciate what is presented in pictorial form than what is just left on a table. So for you to have confidence in your data, it must be repeatable. That is, when you repeat that same experiment within same condition, it will give you the same result. But when you take it to another lab and repeat it, it will give you the same result. If it gives you another result different from what you have got, that means there's problem in your data. You have to discard it. That means there's a problem, error of setting. Understand? So that means you need to formulate a new hypothesis. Understand? It must be reproducible. That is, other people from different countries, if they follow the same method they use and the same condition, they must have the same result. Understand? That's why you have to be careful when you are planning and designing your experiment. That's what you have a good result, and not to present a biased result. And it must be valid. Valid means that your data must answer the original question. It must support your hypothesis. Did you get it? So these are the things that will make you have confidence in your result. So the next one is a joy conclusion. Drawing conclusion means asking yourself a question: does your data support your hypothesis, or does it refute your hypothesis? If you refute your hypothesis, that means you have to discard your hypothesis or formulate a new one. Or sometimes you have to make a new hypothesis and inconsistent with the observation you got from your experiment. Understand? So, but if you report it, that means your confidence in your data will grow. Understand? And this will lead you publishing a work, or that's to see what you have done. So you can publish your work on through a journal, or by presenting it in a conference where scholars from different parts of the country come to see what you have done. Understand? So one of the vital goal of the peer review is that experts in your field, we look into your work to see. Their goal is to check whether there's a problem in the method you have used, or if there is a problem in the conclusion you have drawn through that method you use. Because that's why you have to be careful when you are planning your experiment. You have to be careful when you are analyzing your data. You have to be careful when you want to present your work. So the scientific method is very, very easy and sweet if you understand how it really works. So after your hypothesis have been supported by many evidence, it can become a law or theory. Let me explain the difference. A law is something we have observed many times and we have seen that it is true anytime we test it. For example, the Newton's second law, that when the force apply on an object, the object will accelerate in the direction of the force. This is a law. A law does not tell us why it happens, but it is something we have observed many times to be true anytime we test it. A theory tells us what really happened, because there are many evidence to back it up. In fact, a theory is any hypothesis that have been supported by many evidence. That is, people from different parts of the world they have tested their hypothesis, and they have evidence to back it up. You can see scientific method is very, very sweet if you really understand how it really works. It's very easy and simple. Science is very interesting if you understand the scientific method very well as a scientist. Very, very important you know it and be able to apply it. Not to turn your idea into things that will bring benefit to man and also contribute to the life of many. So please do subscribe to my YouTube channel. And one thing I want to ask you, I hope you really enjoyed this topic we just treated. Please be sure you visit my channel, because you are going to get insightful ideas, tips, and innovation. This is academic channel, and my goal is to help you get better in your academics. My name is Igwe Chijoke. I am a teacher, and I'm also a chemist. So feel free to visit my YouTube channel. Feel free to ask questions. If there's something you don't understand, I will gladly give you the positive response you need. Thank you for visiting my YouTube channel. Bye bye.